Alright, welcome back to Let's Go Over Multivariable Calculus. Today we're gonna go over overview of function. Right, so today we're just gonna talk about introduction to function. So let's talk about what a function is. So when you think about a function is something that takes some input and give you some output in one variable. It's kind of like function that you know. So function in one variable look like this. You have f(x) equal to x squared. You input x, you output x squared. If your input is 4, your output is 16. If your input is -2, your output is +4, right? So function is just something that associates input and its output. But in this class, we talk about vector calculus or multivariable calculus. So we will not be looking at this kind of function anymore. We will be looking at function that either have several inputs or input is a vector. So function that we are interested in look like this. We have f of x and y equal to xy squared. These will be our inputs, right? Instead of just plug in one number, you can plug in two numbers in our function, and output is xy squared. I'd like to discuss this a little bit because this will be our main object to talk about for the rest of the course. What should you think about this function? Well, when you see this kind of function, you can think of it in two ways. You can think of it as a function that has several inputs, right? You plug in x, plug in y separately, and the output determined by your choice of x and y. Or you can think of this function as a function that you plug in a vector xy, right? Since a vector x has two components xy, it makes sense to talk about f when you plug in one vector x and output is xy squared. So we will use these two ideas interchangeably, and it's important to understand that we can view the function in both ways. Let's talk about graph of a function. If I need to summarize graph of a function like this in one word, I would say it's hard. Usually people don't ask you to draw a graph of a function, but let me explain the idea behind graph of the function to you. When you have a function f(x,y), graph of function is just a set of points that is height determined by the corresponding xy. Right, so what do we mean by that? Let's look at one example. Alright, so x squared plus y squared is our function. So let's look at how would one understand the graph of this function. The graph of this guy will be some sort of surface, and the height of the graph will be determined by the output of the function. So this is the height. For each xy, the height will be x squared plus y squared. When xy equal to 0, 0 or the origin, x squared plus y squared also equal to 0. When you see this kind of equation, you think that at xy equal to 0, 0, you go up by 0 because that's your height. So you reach this point. Alright, so let's move on from xy equal to 0, 0 to xy equal to 1, 1. Now x squared plus y squared will be 2, which means that if you look at the point x equal to 1, y equal to 1, your graph will go up to 2. Alright, so this is point 1, 1. At this point, the graph should go up to 2. Right, so this is actually a poor way to draw a graph because you will not get entire surface just by plugging in a bunch of points. But it's very essential a way to understand or to read the graph of the function. For this one, let me just give you the answer. When you have f(x) equal to x squared, this is a parabola. X squared plus y squared is simply a 3D parabola. So what do we mean by this? And to relate these 2 points to the surface that I just drew, these 2 points are points on the graph. Alright, so graph of a function is hard to draw. So what is a more popular way to explain multivariable function graphically? Well, we usually do level curve or contour lines instead. So let's talk about that. Alright, so this is an alternate way to draw a 3D graph. The inspiration behind this is think of a weather channel. Alright, so suppose this is a map of your city, look like an area like this, and you go on to the weather channel, they tell you kind of like temperature map that look like this. You might find a weather map that look like this, right? They draw a bunch of lines and they label on each line they label temperature, which mean what? Which mean if you stand right on this line, then you just trace on this line, you see number 70, you know that temperature at your place is 70. If you stand here, you don't have a line, but you can kind of guess. You are halfway between 80 and 90, so you guess that your temperature might be 85. And that this is precisely level curve and control line. This number will be output of the function, and we will draw line around set of points that has the same output. Alright, so let's go over how to draw control lines. Alright, so first you select some choices of outputs. So just like in the previous example, we do 60, 70, 80, and 90. Right, so there's no reason why we should skip 85, there's no reason why we should stop at 90, right? But we just select some that will represent. Alright, so sometimes the problem just give to you, ask you to draw contour line for specific levels, but if they don't tell you, just select the one that you like. Alright, so step 2 is, for each k from part 1, we draw the graph of fxy equal to k. Important take on step 2 is that this has no z in this equation, which means this equation is equation of two variables. Therefore, we can draw the graph of this equation on a plane, on an xy plane, instead of xyz space. Last is we're gonna keep doing step 2, right? Because we select a bunch of outputs. In step 2, we draw one graph. Step 3 is we keep doing step 2 but for different outputs. But make sure that you draw all the graph on the same xy axis. Let's see this in action. Alright, so let's do level curve for these particular levels, k equal to 1, 2, 3, and 4 for this function x squared plus y squared. Alright, so what do we do? For each of these guys, we set formula of the function equal to those constants, and when we draw a graph. Right, for k equal to 1, the equation will be x squared plus y squared equal to 1. And now you use knowledge of your previous math courses to draw a graph of this guy. As you might recall, the equation x squared plus y squared equal to r squared is the equation of the circle of radius r. In this case, it will be a unit circle. Just like in weather map example, we will label each curve by its output. So in this case, we plug in k equal to 1, so we label this curve 1. Alright, and then we repeat the process for the rest of the levels. For k equal to 2, just equate x squared plus y squared to 2, so we have x squared plus y squared equal to 2. Try to draw this function, but more importantly, we draw this graph on the same plane, right? So again, this is in the form of x squared plus y squared equal to r squared. Radius for this circle is square root 2. Here is square root 2 square. And we keep doing, right? So this will be circle of radius root 3. And we label 3 because we plug in k equal to 3. And last but not least, for 4, we have circle of radius 2. Alright, and that's how you draw a level curve of this function. Alright, so that's all I want to talk about function today. So next time we will dive into a little deeper understanding of function. In particular, this will be the first time that we're going to talk about aspect of calculus in multivariable function. Alright, see you next time.